All right, so these are the forces given to us. Okay, now to find a resultant, let's resolve each force into the various components. Okay, but that will be the approach in solving this one. So let's take this to be F1, F2, F3, F4, then this is F5. So a table of the forces this is summation, this is X component, this is Y component. F1, F2, F3, F4, and then F5. So if let's begin with F1. F1 acts at an angle of 60 degrees to the X axis, then 30 degrees to the Y axis. Okay, so F of X, of course, is equal to 15 times cos of 60, which is the same as 15 sine of 30, don't forget. And F of Y would also be 15 sine of 60, which will also be 15 cos of 60. Okay. Cos 60 is half. So this, the horizontal component of this would be 7.5 Newton. Okay. Then the vertical component of this will be 7.5 root 3. And plus, what is 7.5 root 3? Or 7.5 times 0.866. What is, give me the value in decimal.
12.99.
1.9.
12.99.
Okay. So let's take this to be approximately 13. If you use 12.99, you are not wrong. Then F2, I'll use the same space. So let me clear this. F2 is along the X axis. So it means each component along the X axis is 19. It has 0 component along the vertical axis. So you let me, okay, let's bring the unit here, slash unit. So we will not be repeating it. Another way you can do the same thing is that it makes an angle of 90 degrees with the X axis. So 19 sine 90 is the X component, and 19 cos 90 is the Y component. Sine 90 is 1. So it's still have 90 because 0 is cos 90 is 0. This will be 0. Another way out is that it makes an angle of 0 degrees with the X axis. So 19 cos 0 as again 19 sine 0. Cos 0 is 1. Sine 0 is 0. So both ways would give you the same result. Please, class, are we okay?
Yes, please.
Oh, F
Please, can you
three.
come again?
Okay, what I'm saying is that if you look at F2 is on the x-axis. So it has 19, a magnitude of 19 on the x component or x-axis and 0 on the y component. And another way to do the same thing is that look at the angle it makes with the y-axis. It makes 90. And when you are considering the angle it makes with the y-axis, the order of the coordinate or component is sine cos. Okay, so if you are using the angle mixed with the y-axis, we have 19 sine 90 as against 19 cos 90. Sine 90 is 1, so this will give you 19, cos 90 is 0, and so this will give you 0. That is when you consider the angle it makes with the y-axis. Are you okay?
Yes, please.
Another way out is to look at the angle it makes with the x-axis. The angle it makes with the x-axis. What's the angle that the vector, the force makes with the x-axis? What's the angle? What's the angle here? 0. Yes, it's 0. It's the force lies on the x-axis. So it's 0. So if you are looking, considering the angle it makes with the x-axis, then the order of the coordinates will be cos sine. Okay, so this will be 19 cos of the angle it makes with the x-axis, which is 0, and 19 sine of the angle it makes with the x-axis, which is 0. And so cos 0 is equal to 1, so 19 sine 0 is equal to 0, 0. So it gives us the same results as what we've even looked at earlier. Please, are we okay?
Yes, please.
Okay. F3. F3 is also along the negative y-axis. Okay. So as we can see, the angle it makes with, if once it's along the vertical axis, along the vertical plane, it has no component along the x. So x0, y, the component along the y-axis is 22. But this point to the negative y-axis, so minus 22. So these are the x and y component. Another way to look at this, what is the angle this vector of force makes with the y-axis? Sorry, x-axis. The angle it makes with the x-axis is 90. So 22 cos of 90, then 22 sine of 90. But the vertical component falls within a negative y, so minus this. Cos 90 is 0, so this is 0. Sine 90 is 1, negative 22. So 0 minus 22. You can also look at the angle it makes with the y-axis. What angle does this force make with the y-axis? Yes. What angle does it make with the y-axis? Class, what angle does that cos 22 have to limit with the y-axis?
180.
Oh, open your eyes. The angle the force 22 makes with the y-axis. If it makes an angle of 90 degrees with the x-axis, and this is the x-axis, 90. What angle does it make with the y-axis? Class, yes?
0.
0. 0. So when you're considering the angle it makes to the y-axis, it is sine cos. So 22 and 0, okay, and then 22 cos 0. The vertical component falls to the negative, so minus sine 0 is 0, whereas cos 0 is 1, which will give you the same result. So there are a lot of ways, okay, of doing this. F4. F4 makes an angle of 30 degrees with the x. So 11 cos 30. But this x component falls within the negative x and so minus. Then what's the angle this makes with the, okay, what's the vertical component? So 11 sine 30. The y component also falls within the negative y, so minus. Cos 30 is 0.866. So multiply 11 by 0.866. Yes.
9.5.
9.53. Okay. So minus 9.53. Sine 30 is half. So this is minus 5.5. Minus 5.5. Another way out. What angle does F4 makes with the y-axis?
60.
60. So we can also, the angle it makes with the y-axis, 11 sine 60 by the x component. Okay. And this is minus. And 11 cos 60 on the y component. Sine 60 is root 3 on 2, which is 0.866. So when you multiply that by 11, it will give you the same thing. 460 is half. Okay. And this also falls within the negative y-axis, so minus. So 5.5. Whichever way we look at it, the value is the same. Class, are we okay?
Yes, please.
F5. F5. The angle it makes with the x is 45. The y is also 45. So 16 cos 45. The x falls within the negative x, so minus. Then the vertical 16 sine 45. The vertical would fall within the positive y, so that's it. And cos 45 is root 2 on 2. So this is 8 root 2. What is 8 times square root of 2?
11.31.
Minus 11.31. Then sine 45 is the same value. So we have positive 11.31. So these are the coordinates of each, or the components of each force. The components of each force. Any question? Class,
No,
any question?
please.
All right, then let's look at summation of each one. Summation of x. And then summation of y. Sum them up for me. 7.5 plus 19, which is 26.5, minus 9.that minus 11. We need to have positive. So this is 26.5 minus, this will be maximum 20, even 20.84. Please, what did you get?
Please, the sigma x.
Yeah.
I had 703.
No, look at it.
5.66.
5.66. You see, that's what I was saying. This will give you 26.5. And this will also give you 20.84. So 26.5 minus 20.84. It should give you this, right? Then summation of y. 13 plus 11.26. So this is 24.31 minus, okay, minus 27.5. So it should give us a negative value. What did we get?
Negative 3.2.
Minus 3.2. Thank you. Now, after getting the total summation of x, summation of y, the next thing we have to do is to draw x and y axis. X minus x, y minus y. Summation of x is along the positive x because the value is positive. So this will be along this part of the x coordinate. Summation x is 5.66 Newton. And summation of y is negative. So it will be somewhere here along the minus y. So we have summation y giving us 3.2. Here you see I'm not repeating the negative because the negative gives us where the vector has to be. By having negative 3.2, the idea is that the force will act along the negative y. So there is no need of me repeating the negative because I've taken account of that. That is why it is pointing to this direction and not upward. Please, are we okay? Are we okay?
Yes, please.
Good. So now look at that as we do in vectors. Of course, it's here. Another vector is here. Their directions doesn't follow any orderliness. So we have to realign their direction. Okay, equal vectors. Vectors are equal when they have the same magnitude, direction, and wherever they are. So when you look at it here, this direction, this direction, so the resultant will be here. So here it's obvious the resultant will be along the diagonal because of equal vectors approach. So this is also summation y, which is 3.2. So look at the direction of the horizontal and this one. And they are perpendicular to one another. And so we use Pythagoras theorem to find the resultant. Please, class, find the resultant for me. Start work. Find the resultant for me.
6.5.
Okay, thank you. So when you use Pythagoras theorem, this resultant is equal to summation of x squared plus summation of y squared. So this is 5.66 squared plus 3.2 squared. R therefore will be equal to square root of 5.66 squared plus that. And the answer is 6.5 Newton. That's the resultant. Okay, so yes, some of you, out of the number that were able to submit, yes, some of you got the resultant, but the direction was not directing. The direction never directed. So let's look at the direction of the resultant. First, I have to determine this angle. This angle, the resultant makes, because I realize it will be within this quadrant. Okay. So if that is where it's supposed to be, then I have the opposite, I have the adjacent. Once you have opposite and adjacent, which appropriate trig ratio, even though I know we found the resultant, so we more or less have all the sides of the right angle triangle. But when you have the opposite and the adjacent, which appropriate trig ratio would you use to find theta? Yes.
10.
10. 10 will be the obvious. Okay. So if we use that, then we will have tan of the angle. Excuse me, I'm coming in. Oh, okay. Move. So if you take tan of the angle, this is equal to the opposite this side summation y on the adjacent summation x. So tan theta is equal to 3.2 on 5.66. So take that ratio and then give me the final answer. What is 3.2 on 5.66.
0.57.
Come again.
0.565.
So tan theta is 0.565.
65.
But theta will be the tan inverse. Will be the tan inverse of this decimal value. So do that for me. I think that is 29 degrees.
29.4.
29.4. Good.
0.5.
Okay. So 29.5. Now, what does it mean? It means that if you are at the positive x-axis or due east, you have to turn through this direction or angle to face where the resultant is. Okay, in bearings, angular measurement is always taken from the north. So, what of if I'm at the north? Okay, then it means that I have to turn through this whole angle in a clockwise direction to get the direction of the resultant. So once I have this angle and I'm coming from the north, all that I do is add 90 to what I had. So the direction of the resultant from the north will be 90 plus 29.5. Okay, which must give us 119.5
0.5.
from the north, or 190.5 north of what? North of what?
South.
South. So there are with directions. Okay, it depends on where you are taking the measurement from. You can take the measurement 29.5 degree from the east. So from the east, I have to turn through an angle of 29.5. Or I can conventional angular measurement is taken from the north. So when I'm at the north, okay, through what angle must you turn to face the resultant? That's okay.
Yes, please. So, Mr. Dia, please, you write 119.5 N is north south.
North of south.
Okay.
Okay. Or just 119.5 degrees from the north. Or 29.5 east of south. Do you get it?
Yes,
So
please.
there are quite a lot of ways to handle this, and it's acceptable. All right. Let's try another question. If you don't have any concerns to seek clarification, let's try another question. Yaba,
Yes, Stadia.
did you send your solution?
No.
Yaba, why? Testing. Oh, she's not here. Mhm. Okay, so I'm drawing it. Okay, it's a diagram, so I'm drawing it on the board. Okay, so the first question demands that we answer or we explain what an equilibrium of forces. What is an what is equilibrium of forces? What is equilibrium of forces? Then I'm coming in. Let me change the marker. Give me a second, I'm coming. Yes, what is equilibrium of forces? Any idea? If you have an idea on what equilibrium of forces is, please share it with us. Then we have this diagram. This is a force of magnitude 60, 60 Newton. Then another force of magnitude 100. The angle between them, when we extend this, this is 60 degrees, and then this is 45. Then we have this force of magnitude 50 Newton. We have to calculate the magnitude and direction of the resultant. Calculate the magnitude and direction of the resultant of the forces. Of the forces shown in the figure above. Then we have to find also the magnitude and direction of the equilibrium of the forces above. So A and B. Find also the magnitude and direction of the equivalence of the forces above. So this is the problem. This is the problem. So once this is okay, more than the number of forces, okay, goes beyond 2, more than 2, then we have to resolve each force into x and y components. So do that for me. Start with resolve each of them into x and y components. And once this one is along, this 2 force is along the x, and so when we rule a vertical line, this will also be the y, positive y, and then the downward will be the negative y. So maybe in about 3 minutes time, I'll come back to you to see whatever you got for the components of the force or of the forces. Finish?
Sir, please, I can't see what you've written on the board.
Okay, let me take a shot and send it to you, okay? It's forwarded to the group, okay? So if you can't see, I'm sure you can pick it from there. Are we through?
Yes, please.
Okay, so let's see what we got for the components. So we discuss it and then you use that to assess whatever you were able to do, okay? By the way, okay, there's a question on the equilibrium. So let's hold on with this. We'll discuss it. So if I have three forces, so X and then Y. If I take this 60 Newton force, the 100 and the 50 Newton. The component of the 60, the X component would be, since the angle it makes with the X axis is 60, this will be 60 cos 60, and that will be 30 Newton. Then 60 sine 60. So 60 times 0.866. What is 60 times 0.866?
51.96.
51.96. And their both components will be okay within the first quadrant. So positive, positive. Okay. Then the 100 Newton. The 100 Newton is 45 degrees from the x-axis. Okay. So 100 cos 45. So we have cos 45 is root 2 on 2. So 50 root 2. So 50 times 1.414. 50 times 1.414. Yes,
70.71.
70.71 Newton at the X, and the negative of it as the Y. Please, are we okay?
Yes.
Then the 50 Newton. The 50 Newton is along the X axis. So negative 50 Newton as the X and 0 Y. Summation. This is 100.71. So minus 50 will be 50.71 as summation of the X. Then 70.71, 51.96 minus 70.71. Yes,
Negative 18.75.
negative what?
18.75.
So let me see by hands, those of you who got this. I'm counting. Okay. All right. So if you didn't know, please, this is the the solution pertaining the components. Now, having had the components, we can now go ahead. Stephanie, Stephanie, your hand is up. Or Stephanie.
So this was from the previous question you
Okay.
asked. Sorry.
All right. So let's draw because we will need the direction. It is for the direction. Okay. Why we have to eventually draw. So my x and then y. My summation x is positive. So summation x positive 15.71. Summation y is negative. So it's here. This is 18.75. Let me create space for the writing. So 18.75 Newton. Summation y. So which on which direction, okay, are we going to have the resultant? Will it be on the x or y or where? Yes. Where would the direction of the resultant be?
East
We've been
of
doing this.
south.
Pardon?
East of south.
Precisely along the
X.
along the diagonal. When you create an equal version of this and bring it here, it will be along the diagonal of this triangle. So it will be along the diagonal, okay? But this will be R. So help me find the value of R. Help me find the resultant. Yes. What did we get for the resultant?
$54.1.
Okay, so let me also do it so you mark yourselves. So R would have to be summation of the square root of summation of fx squared plus summation of fy squared. Fx 50.7 plus 18.75 squared. Is that what the final answer?
54.1.
Come again.
54.1.
54. Okay, let's find the direction. So, in determining the direction, let's find theta first. The direction R makes with the x-axis. So help me get that first and foremost. The direction R makes with the x-axis. Are we through?
Please, you get 20.30.
20.30.
Yes, please.
Okay. Who else had the same thing? Mention your name if you got it. You got the same answer. Okay. All right. So tan theta is equal to summation y on summation x. 18.75 over 50.7. So theta is equal to the tan inverse of 18.75 on 50.71. And then you got 20 points.
Um, 20.30.
Okay. 20 points.
3.
Okay. Degree. So the direction of the resultant is 20.3 degree from the east. Okay. So if you are at the east, you have to turn through an angle of 20.3 degrees to face the resultant, or 20.3 plus 90 from the north would also give you the same direction. Okay. All right. Then
Yes, please.
the B part demands that find also the magnitude and direction of the equilibriums. Okay. Now, what is an equilibrium? The equilibrium force, or the equilibrium of a force, is that force which would give a, or which will produce a net force of 0. So that force, when applied, would give a net force of 0, okay, in a system. So if you have, this is a system of forces acting concurrently. These forces are acting at the same time on a point. Okay. And so 60, 100, 50 Newton force acting in different directions. The resultant force which we got, 54, is the effect produced by all the forces. So we define the resultant force as that single force, a single force that can produce the same effect as a number of, as the effect produced by a number of forces. So what it simply means is that literally, what it means is that what all the three forces acting in this manner can do, only the resultant force of magnitude 54.1 can do the same thing. So what three forces can do when acting in this manner, only that single force we are calling as the resultant can do it. So we defined the resultant force as excuse me, I'm coming in. Okay. Okay. Yeah. All right. Yeah. Very necessary. So the resultant force is that singular force that we can produce an effect equivalent to the combined effect of this number of forces. Now an equilibrium comes in. With the equilibrium, it is that single force which would cause the total forces acting at a point or in a system to be zero. So the equilibrium is to come and set the system into equilibrium. Okay. In physics, if we talk about an equilibrium state is where the total forces or the net forces acting on a system is equal to zero. So when the equilibrium force comes in, the total forces acting is equal to zero. So find also the magnitude and direction of the equilibrium of the forces above. Now, one way of determining the equilibrium is that the equilibrium, because we want the total force acting on a system to be equal to zero, the equilibrium must have the same magnitude as the resultant. And but have a direction opposite to the resultant. So because when the equilibrium comes in, it comes to set the system in equilibrium, the equilibrium must have the same magnitude as the resultant. When I'm coming to fight with somebody, and to ensure that the fight, nobody wins, then whoever is coming to fight me must be selected in such a way that he has the same strength as myself. So the inputs I make, he makes the same thing. I fight this way, he will fight oppositely. Then I can say that, oh, then at the end of it, there wouldn't be any winner. The number of punches I give, the person must give the same number of punches. Now, if somebody is selected and the person is stronger than I do, oh, there will certainly be a winner in no time. Is that okay? So the equilibrium, here I'm the resultant, and you are bringing in somebody who would ensure that there is no winner. Then I must be giving somebody whose strength or number of punches will be same as myself. Please, are we okay?
Yes, please.
So when the equilibrium comes in, the net force acting on the system is zero. Now, look at the direction of the resultant. The resultant is acting in this direction. The equilibrium must have the same magnitude. So the magnitude of resultant was 54.1. Meaning that the magnitude of the equilibrium must also be 54.1. But its direction must be opposite to the direction of the resultant. So the equilibrium must act in this direction. Okay, now what is the direction? This is where Nana, mute yourself. This is the equilibrium must act opposite to the resultant. Same magnitude, opposite in direction to the resultant. Okay, so let's determine the magnitude of this. If this is 20.3, okay, this will also be 20.3. 20.3. Please, do you agree with me? If this is 20.3, yes, we got theta to be 20.3. This must also be 20.3. Agreed?
Yes,
please.
yes.
By what principle?
Opposite angle.
Vertically opposite angle.
Vertically opposite angles. Now, if this is 20.3, what would be this angle?
90 minus 20.3.
Good. So, if we are at the north and we want to determine the direction of, I'm always making reference from the north because that is the conventional, okay, conventionally, angular measurement in bearing is from the north. So, when you subtract 20.3 from 90, do that for me.
69.7.
69.7. Okay, so if you are at the north, the equilibrium has to be 69.7 counterclockwise. Okay, or this is the resultant. The reference is the resultant. Okay, if I'm at the resultant, this whole angle is 20.3 plus 90 plus 69.7 would also give you the direction of the resultant of the equilibrium from the resultant. So once we have identified the resultant, the direction of it is opposite. Okay, and this must be 180. I think when you add, it must give you 180.
Yes, please.
Good. So either 69.7 from the north, okay, 69.7 from the north, or another way of conventional angular measure. Either here we are measuring it anti-clockwise, in an anti-clockwise direction. We can also be here at the north and still follow the direction of the equilibrium. Okay, so here we are going through this 360 minus 69.7 would also give us the direction of the equilibrium from the north, but this time in the normal way of measuring angles in bearings. Okay, another way of solving the same question, determine the direction, the magnitude and direction of the equilibrium is this. Let me clear this part. What are the coordinates? What are the coordinates of the resultant? Resultant, we've got the coordinates or the components to be 50.71 and minus 18.75. The X and Y components. Now, let the equilibrants be maybe R prime. Now, when the equilibrant is added to a system, the net force is 0. So R prime plus the resultant must give us a net force of 0. R prime, therefore, what are the coordinates of the resultant? 50.71 minus 18.75 is equal to 0. Okay, by this, I want to determine the component of the equilibrant. The component of the equilibrant will be minus 50.71 and then 18.75, meaning this component or coordinate is crossing the either equal sign. Please, are we fine?
Yes, please.
Okay. So if these are the components or the coordinates of the equilibrant, let's draw it. Okay. Let's draw it as we did for the resultant. The x is a negative, meaning, let me push my axis up. X, y. My x component is a negative, meaning it's along this side. So we have summation x, which is 50.71. Okay. Then my y is a positive. Okay. My y is a positive, which will be summation y, and that is 18.75 Newton. What will be the direction of the resultant in this case? Where will the resultant be?
Diagonal to.
Good. It will be along the diagonal. So using Pythagoras theorem, I can find this resultant, and the resultant is the equilibrium. So R prime will be equal to square root of 50.71 squared plus 18.75 squared. And that's the same thing we did for the resultant. Let me draw your attention to it. This is what we go for. Okay, the same coordinates, 50.7 squared plus 18 point. So it means that the equilibrant would have to get the same magnitude as the resultant, as I said earlier. So 54.1 Newton. Then direction. Let's determine the angle between the resultant and the x. So far, once we have the vertical component, we have the horizontal component. Sum of alpha will be equal to 18.75 on 15.71. What will be alpha? Please calculate alpha for me. The same value, 20.
0. Okay.
Okay, so Let me draw your attention to what we were doing here. I earlier was saying that when this is theta, 20.3, this is also be 20.3. Okay, but what this means is that this direction, this theta we are getting is an angle of 20.3 degrees from the west. That is, it was from the east or x. Okay, when we measure this angle, okay, from the west, we get the direction of the equilibrium. Or when we subtract this angle from 90, we get the angle from the y-axis or from the north. Okay, which will basically be the same thing as we analyzed earlier. Please, is it well understood? Or if you seek some clarification, let me know quickly. Is it well understood?
Yes, please.
Yes, please.
No question? Okay. So this is
Mr. GRP. So, what will be the direction?
so the direction will be either 20.3 from the west or 69.7 degree from the north in an anti-clockwise direction, because here you have to measure in direction to face the resultant, the equilibrium. Okay.
Thank you. Yes.
As I said, or what we measured, the equilibrium is here. This angle is 69.7. Okay, 69.7 degrees from the north. But when you are measuring it, it has to be anti-clockwise. Okay, so usually minus 69.7 degrees. The minus indicates that it's an anti-clockwise measurement. Or I can also measure the direction from here. If I'm measuring from the north in a clockwise direction, all that I do is to subtract 69.7 from 360 minus 69.7, and I have the direction. That will be 200 and what?
290.3.
Okay, so 290.3. Here's another direction. With this, everybody knows that for bearing angular measurements, start from the north and then in a clockwise direction. So when I measure 290.3 degree from here, it will also give me the direction of the equilibrium. Okay, I think I have a similar question. Let me forward it to you so you can train your strength or build your capacity with. So I'm coming. Give me 1 or 2 minutes to retrieve the question, okay?
Yes, please.
We have what, man?
Mr. Dia.
Have I solved your question?
Yes, please.
Okay. But it's good you forwarded the question to me. At least it has given us something to smile about. Oh, where would this question be? That's why I most often want to forward it to the group first and foremost. This time I was teaching. Mm, 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 mm. Okay. The next area we want to look at is forces. Okay, we'll look at forces. What is a force? Yes, what is a force?
A force is a pull or push of an object.
A pull or a push of an
Of an
object. All right. Now, let's talk about some types of forces. What are some of the types of forces you know of? There can be a lot. Yes, there can be a lot, but forces are grouped into two main categories. Okay, I think I have the question. So I'm going to send it to you. We are doing it right now. It's not an exercise where you submit later. No. Mm. Okay, so it's been sent. Let's check. It's been sent. We have the forces F1. We have the forces F1 is given as P Newton, meaning the magnitude of the force F1 is not known. P Newton acting at an angle of 30 degrees. Then F2 is 2 Newton acting at an angle of 45 degrees. Okay. And then F3, 5 Newton acting at an angle of 90. F4, Q Newton acting at 150. And lastly, F8 acting at F5 of magnitude 8 Newton acting at an angle of 60 degrees. Please here, the angular measurement is from the north. Okay. Oh, sorry. F5 is 8 Newton acting at an angle of 270 degrees. So we have F1, F2, F3, F4, and 5. They are acting on a body in equilibrium. We are to calculate to two significant figures the forces P and Q. We don't know the forces P, Q. We are to calculate it. Class, okay? The trick
Yes,
is
please.
that resolve each one into components. And they are acting on a system in equilibrium. All the forces are acting on a system in equilibrium. Please, what does it mean? If a number of forces are acting on a body are said to be in equilibrium, what does it mean?
It means all
They
the
balance out.
Yes. So the effect, the total forces, the effect of all the forces is equal to 0. Okay. So we have to find the forces P and Q. So resolve each one into components first. Maybe because we have so many forces have to be guiding. So first resolve each of them into components. Are we on?
Mr.
Okay.
Dia.
Hello.
Please, are we solving it right now?
Okay. You know what? Let me give you a simple one to do to solve right now. Then you play on this later, okay?
Yes, please.
Because once this is about 5 forces, maybe it can take your time. So I've sent another one. I've sent another question. Example 2. Maybe answering this will help you get that. 2 forces P of magnitude 4 Newton acting at 60 and Q of magnitude 2 acting at an angle of 225 act on a body. Find the magnitude and the direction of the third force that will keep the body in equilibrium. So P has magnitude of 4 and direction 60. Q has magnitude of 2 and acting at an angle of 225 or in a direction 225 degrees from the north. Find the magnitude and the direction of the third force that will keep the body in equilibrium. What name will you give to this third force that would keep the body in equilibrium? What name? Class, what name will you give to this third force that will keep the body in equilibrium?
Equilibrium force.
The equilibrium force. Okay, start with. I think do this so you try the other one later. And we are all solving, please. Okay. Finish. Hello, finish.
No, please.
Yes or no?